Click the bell icon to get latest videos from Ekeeda.
Hello friends, now we are going to do a numerical which is based on degree of dissociation, and this is the problem number 3. So let us do it. So let us understand the numerical itself, and for which we have, that is, we have to calculate the percentage dissociation of 0.01 molar NH4OH solution, and the Kb, or we could call it as the dissociation constant for a weak base, that is NH4OH, is been given as 1.75 into 10 raised to minus 5. So this is the thing that they have asked for, and what we have to do is we have to calculate the percentage dissociation. So let us extract the data from this question, and it will be very much easy to solve it. So the thing is, the given data that they have provided to us is, so the given data, the first thing that we have got to know, that is the concentration, and the concentration has been given as, that is 0.01 molar of the weak base, that is NH4OH. So I am writing it over here as NH4OH. And talking about the next thing, that is the Kb is also been given to us. So therefore the Kb, or we could call it as the dissociation constant for the weak base, has been given as, that is 1.75 into 10 raised to minus 5. So in this case we have to calculate, that is, we have to find, that is percentage dissociation, or this is what we have to calculate. So how can we do that? And or percentage dissociation. So let us see that how can we calculate this thing. So but before that, because concentration and Kb, these two values have been given to us, so only thing that is left out is that is we have to find out the first thing, that is alpha, or we could call it as degree of dissociation. And for that we have a formula, that is, the formula is nothing but, that is, if you have got to know, that is degree of dissociation, that is alpha, it is nothing but in terms of concentration. Suppose if we are calculating, so therefore Kb divided by C. So in this case the alpha is not been given to us, so what we are going to do is we are going to substitute the values over of that is Kb, and in this case the value of Kb that we have got to over here as 1.75 into 10 raised to minus 5. So therefore 1.75 into 10 raised to minus 5 divided by the concentration. The concentration is being given as, that is 0.01 molar, and let us calculate this thing. And so let us see what is the answer that we could get over here. So we have got an answer like, that is 0.041, or we could write it as that is 4.18 into 10 raised to minus 2. So therefore this is what we have got the percentage, or we have got the degree of dissociation, and that is basically, this is the one. And now we have to calculate the percentage dissociation. So therefore it is very much easy to calculate, and we know that the formula can be written in this way, that is the degree of dissociation is nothing but the percentage dissociation divided by 100. So therefore we could write it as the percentage dissociation as in this way, that is, and that will be nothing but alpha multiplied by 100. So in this case the alpha that we have got, it is basically as we could see over here, it is 4.18 into 10 raised to minus 2. So therefore we'll write it over here as 4.18 into 10 raised to minus 2 multiplied by 100. So therefore this 2 will cancel out with each other, and the only thing that is been left is 4.18, because we are calculating the percentage dissociation. So therefore this is what we have got over here, and that is the final thing that we have got over here. So that's it friends, and this is how we have calculated the percentage dissociation, and that's it. It was a very easy one, and I hope you have liked this video, and you share this video with friends, and yes, don't forget to subscribe. Thank you so much.